Okay, so we're gonna do 12.3, which is geometric sequences. And then by the end of today, you're gonna be able to find the constant ratio R of a geometric sequence, find sums, and then determine if a series converges or diverges. Okay, and you guys should have done a lot of this last year in Algebra 2 Honors. So the definition is a sequence where the ratio of successive terms is a constant called the common ratio. And we call that R, where R is not equal to 1. And then remember how we said that the arithmetic sequences were linear? Do you guys know what the geometric sequences are? Yeah, exponential. Okay. So our formula that we are going to use for this, for the nth term, is going to be a sub n equals a sub 1, so the first term, and that's times the ratio r to the n minus 1 power. Okay, so remember how I said, like on your pop quiz, if you guys are having trouble, like with number 3, which was writing the equation for that series, was 1 minus 10 plus 100 minus 1,000. Okay, that we'd be going over a formula to help you with that. This is going to be that formula. Okay, so example 1, you guys should have already done this. Hopefully you noticed how similar this was to what we did earlier in the week. Okay, so you're gonna find the first 5 terms of the sequence. Oh, I did not give that to you.
Yeah.
Sorry. Okay, so you guys didn't do that. So it's a sub n equals 2 times 4 to the n minus 1. Okay, good. So if we want to find the first 5 terms, Thomas, for example, how would you find the first term? What would you do for that?
Plug in 1 in.
Yeah, you're going to plug in 1. So this will be a sub 1 equals, and then 2 times 4 to the 1 minus 1. Okay, so this would be the power of 0. And then, Hannah, do you remember anything to the 0 power is what? 1. Okay, so 1 times 2 is just going to be 2. Okay, and then you guys can generate the rest of those. Part B, it says, what is the common ratio R? So remember to find D, we did A2 minus A1. To find R, it's very similar. What you do is take A2 and divide by A1. Okay, so in this case, we found that A2 was 8 and A1 is 2. So if you divide those, you will get 4. Okay, that is what is called the common ratio. Like we did with the arithmetic series, we are going to graph this series as well. Okay, and remember the term number is going to be your x value, and then the output is going to be your y value. Okay, now I have to go up to 512, so what I decided to do was go by hundreds. 100. And then remember, we are not going to connect these points. So the first ones are going to be very, very close to the line. And once we get to A4, we can see a little bit more movement. And A5, we can see the last movement. So if I connected these, wouldn't they form an exponential graph? Yes, they would. Okay, but who can tell me why we are not connecting them? why are we not connecting in this case? Yeah, you remember? Oh, but I said it
But you
yesterday.
said it.
Yeah, I did. What kind of numbers do we use as sequences?
It's the natural.
Yep, the natural number, so the counting number. So all we're plugging in is 1, 2, 3, 4, 5. So we don't have those decimals in between, so we are not gonna connect those. Alright, for example 2, we're determining whether each sequence is geometric. If so, find the common ratio. So last time we decided if they were arithmetic, they had the first common difference. Okay, for this, we're gonna make sure that they have the first common ratio. Okay, and you guys can go ahead and work on this without me if you want. Okay, if you're still a little unsure how to do it, you can follow along with me. So we have A2 over A1. So in this case, your A2 is 1 over 5. So we would say our R is 1/5. Okay, or you could also say 0.2. Okay, and then what you want to do is make sure that you would multiply everything by 1/5 for every term. So 5 times 1/5 is 1. Is 1 times 1/5 0.2? Yes. Is 0.2 times 1/5 or 0.04? Yes. So because the ratio is constant, it's going to be yes. Okay, this is a constant ratio. Okay, so for B, I'm gonna find our R value. Katie, did you find your R value for us? Okay, good. Oh, okay, yeah, so what I do is I always take A2 and A1 and find that, and it's 1/2. Okay, so then and then I take the next two. So I could also do 60 over 90, which would be 1/3. Okay, so 1/2 and 1/3 are not equal, so the ratios are not constant. And you could also find that by multiplying. So for this, it's going to go. Okay, and then this is why, because your ratios are not constant. Okay, for example 3, we are going to find the 7th term of the geometric sequence with the given terms. So for step 1, what you want to do is find the common ratio, and we are going to use that new formula that I gave you today. So I'm going to write that up here. It's A sub n equals A sub 1 times R to the n minus 1. Oh, thank you. Sorry, this is 2/3. So for this one, yeah. So when you're finding the common ratio and you're given A4 and A5, what you can do is substitute those into the equation, and then you can solve for R. So if you substitute A5 in for N, and A4 in for A1, remember with the arithmetic, how the 1 and the 1 were related? This is the same thing. So instead of N, I'm going to replace that with 5. N with 5, and then 4, I'm going to replace with the 1. Okay, so this is in the AN spot, this is in the A2 spot, and then I'm actually going to plug in the numbers as well. So negative 40 equals negative 8 times R to the, in this case, first power, so I can just do times R. So divide by negative 8. Okay, and your common ratio is going to be 5. Okay, for step 2, you are going to find A sub 1. Okay, and if you're finding A sub 1, again, you can use this formula here. And then what I would plug in is A sub 4 or A sub 5. You can use either one. And this would be times R to the 4 minus 1. Okay, and then for A4, I'm going to plug in negative 8. Okay, we just found that R is 5, so this will be 5 to the 3rd power. And then we can do get a fraction, please feel free to leave it like that, especially if the decimal is long. Okay, so I'm gonna keep mine as a fraction. And then step 3, you're gonna write the rule and evaluate. So the rule is, this would be like with the nth term. That's what it means when you're writing the rule. So this is gonna be a sub n equals, and now I'm gonna plug in my a sub 1. Okay, and then I'm gonna plug in my r. Okay, so this is the rule. And then I can just evaluate for what I'm trying to find. So I'm trying to find the 7th term. So I'm gonna do a sub 7. And 7 minus 1 is 6. Okay, and you can put this in parentheses, negative 8 divided by 125, and then times 5 to the 6th power. You can also do 5 to the 6th times negative 8 and divide by 125. Okay, so check to make sure you can get the same answer that I do, which should be negative 1,000.
Can you define a sub 1 or do you plug in?
Yeah, so with, in these cases, when we talk about this, yeah, once you know a sub 5, really, you could just keep multiplying, right? And get to a sub 7. Is that what you're saying?
No, I'm saying like, instead of plugging a sub 1 in, the finding that, could I plug like a sub 4 in, and then,
Oh, yeah, and then just change the 1 to the 4. Yes, absolutely, those are interchangeable. Okay. And really, you could find a sub 7 the way I told you to. So like, if you know this is a sub 5, you multiply by 5, and then multiply by 5 again, that's gonna give you a sub 7. But on your quiz, I'm gonna use big numbers, like 50 and above, so that you will have to go through that process. Alright, good question. Alright, so for part B, you're gonna find the 8th term of the geometric sequence.